Hey everyone, welcome back for another deep dive. Today, we're going to be looking at a research paper
Oh, cool.
that imagines a future
Yeah.
where,
Okay.
you could control all your apps just by talking to them. No more
Interesting.
like,
We're gonna
clicking or tapping or typing.
sign me up for that.
I know, right?
Yeah, sound pretty good.
So the paper is called Large Language User Interfaces, Voice Interactive User Interfaces Powered by LLMs.
Okay.
And it was written by researchers at Ontario Tech University.
Interesting.
So essentially what they're proposing is, like a whole new way to think about
Yeah.
how we interact with technology.
Yeah, so instead of menus and buttons, it's all about using our voices, which is a pretty fascinating concept.
Yeah, for sure. But how does it actually work?
So it all starts with LLMs,
Okay.
which are essentially like super-powered language brains.
Okay.
They can understand and generate human-like text because they've been trained on massive amounts of data. And the idea here is to use these LLMs to kind of bridge the gap between our spoken words and the functions of an app.
Okay, I think I'm starting to get the picture a little bit,
Yeah.
but I'm kind of a visual learner.
Sure.
Can you give me like a concrete example of how this would actually work?
Absolutely.
Uh,
So imagine you're using like a music app
okay.
and you want to listen to your favorite song.
Uh-huh.
Instead of searching for it manually, you could just say, play Bohemian Rhapsody by Queen.
Oh, wow.
The system would then use an LLM to understand your request and then translate that into the specific actions needed to play the song within the app.
Oh, so the LLM is kind of acting like a translator then.
Exactly. It's converting our natural language into the language that computers understand.
Gotcha. That makes sense.
But there's another key piece to this puzzle, which are UI component annotations.
Okay.
Think of these as like labels that describe the function of each element in a user interface.
Okay.
For example, a play button might have an annotation that says play music. These annotations help the LLM figure out which part of the app you're trying to control,
Cool.
even if your instructions aren't perfectly clear.
So it's not just about understanding the words we say, it's about like connecting those words to specific actions within an app.
Yes, exactly.
Yeah.
And that's kind of the revolutionary part here.
Okay.
Instead of developers having to like meticulously design every interaction,
Right.
the system can dynamically generate the interface based on your spoken commands.
Wow.
And this could dramatically reduce development time
Yeah.
and lead to like truly personalized user experiences.
Yeah, that's really interesting. That's pretty mind-blowing, but I imagine there are also some challenges
Of course.
in making this a reality.
Yeah, it can't all be smooth sailing.
Right.
One of the big challenges is designing the right data structure to hold all those UI component annotations.
Okay.
Remember, the LLM needs to be able to search through these descriptions very quickly to figure out what the user means.
So it's like creating like a super efficient library
Exactly.
that the LLM can use as a reference guide.
That's a great analogy.
What other challenges do they highlight in the paper?
Well, choosing and training the right LLMs is crucial.
Okay.
They experimented with a few different models like T5 BERT and Electra,
Okay.
looking for the best balance of accuracy and speed.
Sure, because nobody wants to wait forever
Exactly.
for a command to be processed.
Exact. Speed is key
Right.
when it comes to any kind of voice interface.
And I bet training these LLMs effectively adds like another layer of complexity on top of that.
Absolutely.
It's not like you can just feed them any old data, right?
Right. They need realistic training data that reflects how people actually talk.
Yeah.
We don't speak in perfectly formed sentences all the time.
Right. We pause, we use slang,
Exactly.
we go off on tangents sometimes.
Yeah, we're messy.
Exactly.
So replicating that messy real-world language is essential for training LLMs that can truly understand us.
It makes sense. It's not just about understanding individual words. It's about understanding like the nuances of human conversation.
Exactly.
Yeah.
And then there's the challenge of scaling this up to handle lots of users and complex applications.
Right, because you can't just have it work for one person in a vacuum.
Exactly.
Yeah.
Imagine millions of people using voice commands at the same time.
Yeah, that's a lot of data.
Figuring out how to make this work efficiently and cost-effectively is essential if this technology is going to become mainstream.
Yeah, I can definitely see why this is still in the research phase then.
Yeah.
But even with all these challenges, the potential benefits are pretty amazing.
Oh, absolutely.
Just think about how much easier it would be to use our devices
Right.
if we could just talk to them.
It would be a game changer.
Yeah.
The researchers highlight several key benefits.
Okay.
And they all revolve around making technology more intuitive and accessible.
Okay.
For example, imagine someone who has difficulty using a touchscreen or a mouse.
Yeah.
This kind of voice-controlled interface could open up a whole new world of possibilities for them.
That's a really good point. It's
Yeah.
not just about convenience, it's about creating technology that works for everyone.
Exactly. And even for those of us who are comfortable with current interfaces,
Right.
there are times when voice control would just be so much easier and faster.
For sure.
Imagine being able to control your smart home, your music, even complex work applications, all with your voice.
Oh, yeah.
It could free us from the tyranny of menus and buttons.
Okay. I'm totally on board.
All right.
But let's not get ahead of ourselves
Yes.
before we start dreaming about a voice-controlled future.
Yeah.
Let's take a closer look at how the researchers actually tested their framework.
All right.
They actually built some simple applications to see how it would work in practice.
Yeah, they did.
Can you tell me a little more about those?
They chose an account sign-up form,
Okay.
a weather app, and a calculator as their test cases.
Gotcha.
The simplicity was intentional.
Okay.
Remember, this is early stage research,
Right.
and they wanted to focus on proving the core concept before tackling more complex scenarios.
So it's like building a prototype before trying to mass produce a car.
Precisely.
Yeah, that makes sense.
Start small.
Okay, so let's dive into these examples and see how they brought this idea to life.
Okay, let's start with the voice-controlled account sign-up form.
Okay.
Instead of typing in all your information, you could just say something like,
Okay, so to recap, you're saying that instead of like manually filling out a form,
yeah.
you could just say all the details and the LLM would know what to do with the info.
Yeah, that's the idea. Imagine saying something like, I'm registered under the name Alex J. Turner, but everyone sends their regards to my place at 768 Rolling Rock Street. And for a quicker response, they hit me up at alex.turns@rockandmail.com.
And the system would use those like UI component annotations we talked about to know where each piece of information goes.
Exactly. It would recognize Alex J. Turner as the name, 768 Rolling Rock Street, as the address, and alex.turns@rockandmail.com as the email address, and automatically fill in the corresponding fields.
Wow, that's pretty slick. What about the weather app? How did they make that work with voice control?
For the weather app, they focused on natural language queries about the weather in specific locations. So you can ask something like, could you tell me if I need an umbrella for my walk today around the canals of Amsterdam, Netherlands?
And the LLM would understand Amsterdam, Netherlands as the location and today as the time frame.
Precisely. It would then access weather data for Amsterdam, pull the forecast for today, and let you know if you'll need an umbrella or not.
That's super handy. And I'm guessing the calculator example was similar, but with math problems instead of weather forecasts.
You got it. Users could pose questions like, I've got 24 cupcakes and I need to divide them evenly among my 6 friends. How many does each person get?
And boom, the LLM would figure out the calculation and provide the answer.
It's all about using natural language to interact with these applications just like you would with another person.
Yeah, these examples might seem simple, but they really showcase the potential of this technology, I think, to change how we use computers. It's like they've created a universal translator for human-computer interaction.
That's a great way to put it. And remember, these are just basic test cases.
Right.
The real potential lies in applying this framework to much more complex tasks.
Yeah, it's like taking those first tentative steps before you start sprinting.
Exactly.
Speaking of sprinting ahead, the researchers also discussed some exciting future directions for this technology in the paper.
Oh, yeah.
What stood out to you in that section?
I was particularly intrigued by their discussion of Autogen and Mixtral,
Okay.
which are 2 advanced LLM systems that could take these voice-controlled interfaces to a whole new level.
I remember you mentioning those earlier.
Yeah.
Fill us in on what makes them so special.
Autogen is a framework developed by Microsoft that allows multiple LLMs to collaborate like a team of specialists. You might have one LLM that's great at understanding complex language, another one that's an expert at retrieving information, and a third one that's skilled at generating natural-sounding responses.
So it's like assembling an all-star team of LLMs, each with its own unique skill set.
Exactly. And by working together, these LLMs could tackle much more complex tasks than any single LLM could handle on its own.
So imagine asking your device a really complicated question, and instead of getting a simple answer, you get a comprehensive and well-reasoned response that draws on the expertise of multiple LLMs.
Precisely. It's like having access to a panel of experts right at your fingertips.
That's incredible. And what about Mixtral? How is that different from Autogen?
Mixtral, developed by Mistral AI, takes a slightly different approach. Instead of having separate LLMs working together, Mixtral is a single LLM that's been trained to excel at a wide variety of tasks.
So it's like a multi-talented LLM,
Yeah,
a jack of all trades, master of many.
you could say that it's been trained on a massive data set of text and code, and during that training, it learned to identify which parts of its internal structure are best suited for different types of tasks.
So when you give it a task, it knows which expert skills to activate.
Exactly. It's like having a Swiss Army knife of LLMs able to adapt to whatever challenge you throw at it.
That's pretty amazing.
Yeah.
It sounds like Mixtral could be a game changer for voice-controlled interfaces.
It certainly has the potential. And just like our own brains continue to learn and adapt, Mixtral and other LLMs are constantly being refined and improved as they're exposed to more data and more complex tasks.
This constant evolution of LLMs is what makes the future of voice-controlled interfaces so exciting. It's not just about making small improvements. We're talking about a fundamental shift in how we interact with technology.
And that shift has the potential to make technology more accessible, more intuitive, and more empowering for everyone.
I'm already envisioning a world where I can just talk to my devices like they're actual intelligent beings. No more fumbling with menus, no more deciphering cryptic icons, just pure natural communication.
And who knows, maybe one day we'll even be able to have meaningful conversations with our devices just like we do with each other. But that's a topic for another deep dive, perhaps.
Now you're just getting me all fired up about the possibilities. Before we get carried away, let's take a moment to reflect on what we've learned so far, and then dive into the broader implications of this technology in our final segment.
Sounds good. I'm eager to explore the big picture and see where this conversation takes us.
All right, so we're back for the final part of our deep dive into the world of large language user interfaces.
It's been a pretty fascinating journey so far, hasn't it?
Oh, it totally has. I mean, we've gone from that basic idea, of just talking to our apps
Right.
to exploring like some really, really advanced LLM technology.
Yeah. It's been a wild ride.
It has been. But, I think it's time now to zoom out a little bit
Okay.
and think about the bigger picture. Like, what does all this mean for us? How could these LLM-powered UIs, actually change our lives?
Well, I think on a practical level, it could make technology much more accessible
Right.
for people who struggle with traditional interfaces, as we talked about earlier.
Right, could be like life-changing, for people with disabilities,
Exactly.
older adults, or anyone who just finds current UIs like really confusing or frustrating.
Absolutely. It goes beyond accessibility, though.
Sure.
It could completely change how we learn and use new technology.
Because instead of having to memorize commands or navigate complex menus, we could just interact with devices in a more natural, intuitive way.
Exactly. Imagine a world where you don't need instruction manuals or tutorials anymore.
Oh, man. That would be a dream come true.
You just start talking to a new gadget, asking questions and giving commands, and it just understands.
Yeah, that would make technology so much less intimidating,
Right.
for people who aren't like super tech savvy.
Absolutely. And it could free up our mental energy so we can focus on what we're actually doing
Yeah.
instead of, how we're interacting with the device.
So it's not just about convenience then.
Right.
It's about making technology more human-centered,
Exactly.
more in tune with how our brains actually work.
And the shift toward more natural interfaces
Yeah.
could impact all areas of our lives, I think,
Mhm.
from how we work to how we're educated to even how we connect with each other.
It really feels like it's opening up like a whole new world of possibilities.
It really does.
And the thing is, we're still just in the early stages of this.
Yeah.
I mean, the LLMs of tomorrow are going to be even more powerful,
Or sure,
even
yeah.
more versatile, and even better at understanding us.
Absolutely.
So what we've talked about today
Yeah.
is really just a glimpse
A small taste.
of what might be possible, which is so exciting.
It is. There's so much potential for innovation, and it's all happening so quickly.
It feels like we're on the verge of like a whole new era in computing, where that line between humans and machines is becoming more and more blurred.
Absolutely. It's an incredibly exciting time to be following this technology.
Well, this has been an amazing deep dive. I feel like I've learned so much.
Me too. It's always great to have these conversations.
And to our listeners out there, we encourage you to keep learning about these LLM-powered UIs.
Yes, please do.
There's tons of information available online, including the research paper that we discussed today.
Absolutely.
And as always, we love to hear your thoughts.
Yeah,
What are you most excited about? What questions do you still have about all of this?
let us know.
Share your ideas, in the comments. Keep the conversation going.
Keep diving.
Until next time, keep diving deep and stay curious.
See you next time, folks.